Hey, what's up guys? Welcome back to the Ramsey Custom Shop. Today's project, I've got this dilemma that I've had for really over a year, and you can see my gantry crane right here that I've historically used for loading heavier sheets on and off my plasma table. You guys remember the green one that was there and the black one that was there before that. The black one was a 4x8 table, and it worked perfectly with this gantry crane. I kind of built it around that. When I went with a 5x10 green plasma table, it was no longer wide enough. So really for over a year, I've not been able to use that gantry crane to load sheets, and definitely can't load it around this with even, no matter how the tube cutter is, it won't fit around that. Just not enough, not a good way to get there. And you can see I got room for the front to front load it, and I could potentially back in here with the forks, and reach over the tube cutter if I roll it up next to the machine, but not with standard forks, which is what is on this, kind of shorties. And even with long ones, it would be awkward and cumbersome. So I need to build something today to make the loading and unloading of thicker sheets, like 5x10, 1/4 inch, 5x10, 3/8. So this is kind of what I'm thinking about doing. I've got, a bunch of scraps and stuff out here in the barn, and let's take a look and see what we got. I've got some rectangle tubing that was left over, and these, I wish they were a little bit wider, but they've got about a 1/2 inch of clearance on either side of the forks. So, and those are already cut to the same length. They're obviously all rusted up out here. And then I've got some I-beam right here. I think that's a 4 inch and a 6 inch. I think for what I need, that 4 inch will be plenty long enough. And I can make a, now here's some real heavy wall tubing right here that was from a project. And you see I got a long section of that. I mean, I could use that, but I think it's overkill for what we need. Those sheets only weigh, even a 3/8 5x10, I think maybe is in the 400-pound range. But when you get 400 pounds cantilevered out, you got a lot of weight hanging off the end of it, and you need to support it, because I want to make this long to get plenty of clearance, so that I could reach the center of the table with a 5x10 sheet extended out on the end of the fork. So anyway, guys, that's the introduction there. Let me get to work on this, and I'll bring you along. All right, here's what we got to work with, as I showed you out in the barn. And I want to make these, again, I wish they had a little bit more width, and there's a little bit more clearance on the forks to make it a little more forgiving to get in and out. But I'm going to cut one length off of each tube and stack it up on top. And, and so I need to cut it about, each one about 21 inches. So that's going to take some of it. It's going to take a lot of it off of it. So 16 inches. So yeah, I'm going to cut it so that it fits there, and we'll get it tacked up and see what we can do, and then on the overall length of this beam, get it cut down to what we need. So it's 10 feet long. So we may just leave it its full length. All right, guys. Well, as you see, it's turning out that the tubes are not really going to be long enough to cut the cross pieces off and have the runners. So I went back out to the barn and grabbed a piece of channel. I think it's 6-inch channel, and we'll use that for the cross pieces, and then just leave the tubes for the runners for the forks. And then here you see Fusion 360. I've designed up 3 parts that are going to make a slider lug for the beam, and we're going to cut these out of 3/8 plate, and you can see the tabs on that. And then here's the base plate, and you see the slots, so the tabs will mount into the slots and help just locate it and square it up, you know, for welding. And then on the other side of it, there'll be this lifting lug here, and you'll see how this comes together in a little bit. But so we're going to jump over on the laser now that these have been designed, and we'll get them cut out and get to building. All right, so there's our slider cut out, and then here's a piece of the C channel. We're going to use 2 pieces of this, and these will be our cross pieces, and they're not going to be rigidly welded to the tubes. I'm going to have them bolted together. You'll see how it how it all comes together here in a little bit. But I've got these slots that are a little bit oversized that are going to allow for some movement laterally, again, to make it easier for the forks to slide in and out. So got these rusty suckers up here, and we're just rough cutting some slots into it, and yeah. Now I remember why these C channels were out there just rusting away in the barn. Look how terrible one leg is from the other, and how tall one is. But it'll work for what we're doing here. So let's get it all fitted up. All right, I think I showed a little bit earlier these hex head pieces that I cut out of some 3/8 plate. And the purpose of those is to space up the bolts a little bit wider. They're also cut at the same width as the C channel to kind of lock them in a little bit left to right. It also spreads out the force pulling against the tube over a wider area. But mostly I've got these 7/8 stainless bolts that I wanted to use. I've had them in my bolt bin forever. You know, they're plenty beefy enough and big enough, but they just weren't long enough to reach up through the tube or through the C channel that's going to go on top and have the lock nut fit on there. So I needed these to kind of give it some space up, but also spread the load and the other reasons. So you see here, we're just, this is all rusty stuff, and I got the welder all the way up on high and the foot pedal all the way down, and just feeding the rod in, doing a little, lay wire technique, running over the wire. And then here you see the stainless bolts I was talking about, again, that I've had for a long time, probably like 5 years. I bought these for it was going to be a furniture build back even when I lived in the house at the garage for Hanson 265 Chevy, and that project didn't work out. So finally we're getting to use them. I've used them a couple times here and there, but I had about 20 of them, I think, that I had bought, and so it's good to be able to use them. Okay, so here are those laser cut beam slider lifting lug parts that I made, and you see the tab and slot. Now, one of the things that you can do if you're designing your own stuff is think about what fixturing tools you have available to you and design around those. And so here you see I'm putting the TIG prop rod in place that Reed Eichner sent me very handy. I can't thank Reed enough. I use it all the time on a regular basis, and he took the time to make that and send it to me, and just been an awesome guy and supporter of me and what I'm doing, and so I definitely appreciate that. So I, got it welded square and held it square, and then once it had a chance to cool, flipped it over and did a fillet weld on the other side. So it's kind of welded from both sides, and the tab and slot located it there. So I did have to hit it on the belt grinder a little bit to get the front side fitted up, or the back side fitted up, and you'll see why here in a minute. But you can see the fillets going on, welding the ends first again to try to get as much on there, because putting a big hot weld down one side is definitely going to try to pull it, and you want to immediately flip it around and get another weld on the opposing side to get it to continue to sit as square as possible. So now you see the slider part of it. I'm using the table here to get the first one of those in, and then when I was talking about the design, I left an exact 4-inch spacing between those so that I could use the 246 block in there to fixture it up and hold it square. Again, you see the fillet part of it getting welded in, again using the table to hold it square, and you'll see it get flipped around here in the 246 blocks get used. Over the years, my fabrication skills have continued to improve, and always working on them, always trying to get better. But sometimes, even like this project, you're just kind of working along and everything's going good, and the simple task you're making look easy. The more difficult task, you're kind of just persevering through it, adapting and adjusting. And then a little thing like, let me get this clamped up, comes along, and you realize that the struggle is real and not everything goes easy, and you got to fumble around and fiddle around, and you want to just throw the clamp down and walk out. But just kidding. So you see we got it welded up, and you see the welds all around that. They're hot, they're burned in there hot, and I shoved a lot of rod in there to increase the width of the weld puddle to just focus on strength, but they're really not that pretty for a TIG weld. Some people would ask, well, why are you using TIG? I mean, I just like to do it, and I've mentioned that a lot in videos. When you need TIG, you need it, and it's something that if you don't do all the time, you'll be out of practice of it. And here you see I'm flipping that 246 block and checking it again. Everything's holding square, and that's worked out perfect as a fixturing tool to allow me to clamp it in there and have that beam slider be square. Because if you get that too far out of square, you're going to have issues with it wanting to slide freely on the beam. And when I did the design, I allowed about an 80 thousandths offset in there, so I've got a clearance of just a little bit over a 1/16 of an inch, and it worked out. By the time I got it painted and all that, it worked out to be pretty close to what it needed to be, maybe a little bit loose, but once you get a load on there, it's going to put it in a bind anyway, and it's not going to go anywhere, and you'll see that to be the case. All right, so here you see the C-channel pieces, and I'm just getting those fitted and welded on front and back side. A little bit concerned about the beam and the C-channel, whether it was going to be strong enough or not, but I think it's going to work out just fine. And I had some weird gaps, in some places, but was able to get it all, welded up with no problem. So I'll just let this rip through and let you watch it. All right, well, that's what I've been working on. And again, because I don't have much right and left clearance on the fit here, what I did was, you know, got this top section where it'll bolt on there, and we're gonna use these lock nuts. And I had this stuff laying around for a long time, 7/8 inch stainless bolts that I bought for a project and never used them. Then I cut some 1/4 inch or 3/16 washers there. So this should go down on there and be able to get it like somewhat snug, but lock it with that lock nut so that it's tight, but these have a little bit of room where they can move around. So yeah, I think we're all good. The only other thing I thought about doing is cutting a wedge to go down on that end, you know, because the whole thing's going to want to tilt down this way with all that loose space. But you know, we'll see how it does, and if we need to do something back there, we can do that. But I'm gonna go ahead and get it painted, and we got a 1/4 inch sheet we got to load up, so let's get it painted. All right, so I decided to paint this outside. I was going to try to lug it in the paint booth, but my paint booth's pretty small. It would have fit in there, but it would have just been a pain. And I'm not really worried about making this a perfect paint job. Just want to get some paint on it to keep it from rusting, and because I'm going to keep it outside. But so what I did was, you can see I'm just blowing it all off with air. I had already used a wire wheel to get all the loose rust off and wiped it down once, and that's all I did, and then just blow it off with air. And then what you see I'm doing right here is using Bulldog adhesion promoter, and this is a clear liquid, I'm going to call it primer. It's a lacquer based product. It's inexpensive. It's one part. It dries in about 5 minutes, and it makes a difference. If you're trying to put paint on bare metal that's not really meant to stick to bare metal, it makes a noticeable difference that I found in the metal art. So just lifted it up here to get some underneath it. And then after getting the primer on there, letting it flash off for about 5 minutes, I went ahead and shot some blue base coat. I had this blue aqua color base coat out, and it was actually in my truck from another project I'd worked on over last weekend. And so I just had it handy and thought, you know what, it'll be just fine. It'll be nice and bright, and I don't have any other projects in mind to use this for. So just go ahead and use the blue base coat. You can see I got a mask on. I am spraying outside, and it seemed to be, the overspray is not really that windy, and the wind was generally coming in a direction away from the shop. So, you know, worked out pretty well overall. So this is automotive base coat, clear coat. I don't think I showed it, but I put 2 coats of clear on it as well to give it some, you know, UV protection and lock it all in. And there's the slider down on a little piece I had, 4x4 post I had sticking up there to paint the slider. Yeah, I know that Austin Lanier would have not built anything like this. I know that the C-channel is questionable, probably not strong enough. This 3-inch S-beam, probably not enough. And my fancy-dancy beam lug slider, probably not thick enough. But you know what? Look at this shiny paint job. I mean, we got baby blue shining. No candy paint on this one though.
All right, one of the things I wanted to test out here was, what's the best placement of the magnets? Historically, I've gotten up there and measured out, to get it centered so that it would lift it up without it moving around in the gantry crane. But with the beam sticking out on both ends, I wanted to see if I could just kind of generally place it and then let it tilt in any direction it wanted to and still be able to lift it. So that worked out fine, but I think if I'm gonna do any lifting with it like that, it would be better off having the back come down lower and tilted up in the front. So what I did was I sat it up on this on my table here, work table, and repositioned it, and you see it lifting up the other way now. So when I'm lifting it in the future, I can just easily make sure I line it up so that it's adjusted so that it will tilt down in the back and up in the front. And yeah, so you see it going on the machine here. Got plenty of reach without having to get that close to the machine. And this machine has a lot of, let's say, unused space around it. There's like 2 foot in front of the machine that's a little shelf there, which is kind of handy in some ways. You can, lay the remote control down. You can put magnets and things down there and have a little bit of a work surface. But it's extra space you have to reach over. So, and with a 5x10 sheet, you need to reach, about at least 4 to 5 feet to the center of the plate to get that centered up on the table.